Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here for exercise 5.6. Question number 1. In 2019, the estimated population of Malaysia was 32.6 million people. In one of the survey, it was found that about 57% of Malaysians use smartphone. A sample of 8 people was selected at random. Find the probability that A, 6 of them use smartphones. So, we are given the probability that Malaysians use smartphone is 0.57, which is 57%. So, we get our P is 0.57. And from the P, we can also get the Q. Q is 1 minus 0.57, which is Q equals to 0.43. And then a sample of 8 was selected. So the 8 here is our N. So we have N equals to 8. So A, if we want 6 of them use the smartphones, so we want probability when X equals to 6. So out of the 8, we want the combination of 6 times with their probability 0.57 to the power of 6, and then the failure 0.43 times 2. Alright, because 8 minus 6 we get 2. So check with your calculator, you should able to get 0.1776. B, not more than 2 of them use smartphones. If not more than 2, then we might be X equals to 0, X equals to 1, or maximum X equals to 2, because 2 is not more than 2. Alright, so look for the probability for each of the case. So when X equals to 0, out of the 8, we want combination of 0 who use smartphones with the probability of smartphone power 0. And then the probability of not using my smartphone to the power of 8. Then if Px equals to 1, it with the combination of any one, okay, probability of using smartphone 0.57 to the power of 1, okay, and 0.43, that is the probability of not using smartphone, alright, to the power of 7. And then when Px equals to 2, we use it C2 times 0.57 to the power of 2 and 0.43 to the power of 6, because 8 minus 2 is 6. So the sum of all this probability, we should get 0.0711. Question number 2. On a shelf, there are 3 novels and 2 comic books. A book is chosen from the shelf, and after reading, it is returned before the next book is chosen from the shelf. The process is repeated 3 times. So we see N equals to 3 here. If X represents the random variable of choosing a comic book from the shelf, so we are talking about can get comic book or not. So from here we can see the probability of success P, which is 2 out of 5 books, because we have 2 comics out of the total of 5 books. So the Q will be 3 out of 5. Okay. Then A, construct a tree diagram to show all the possible outcomes. So we are going to pick 3 books, so we have 3 times book 1, book 2, and book 3. Alright, so the probability of getting the comic, okay, and probability that cannot get comic, so K prime. So basically cannot get comic, which is we are getting novel. Alright, so for each, the probability will be the same. Probability of comic is 2 over 5 for the first book. Because of the returning, okay, it is returned before the next book is chosen. So the probability for second comic book is also 2 over 5. And the third book also 2 over 5. Okay. So here are our outcomes. Alright. Then B. Find the probability of choosing number 1, a comic book only once. So we are talking about comic books only one. So X equals to 1. So out of the 3 books, from your N equals to 3, out of the 3 choosing, okay, we want a combination of 1 comic book. So choose 1. Then the probability of getting comic book with the power of 1, and probability not getting comic book with the power of 2. Then we get 54 over 125. Alright. Number 2. A novel 3 times. If we are talking about novel, okay, suddenly from comic book change to novel. So are we getting our comic books? No, right? So if we are sticking to this probability, okay, P is the chance to get the comic book, okay, which is 2 over 5. Now we want out of the 3 choose, okay, out of the 3 times we get all 3 novel. So means that we get 0 of our comic books. So choose 0 of the comic, okay, and the probability of getting comic to the power of 0, okay, and 3 over 5, which is the probability of getting a not comic, which is novel, for 3 times, so to the power of 3, and we get 27 over 125. Question number 3. In a survey, it is found that 95% of the graduates at a university owns laptops. A sample consisting of 8 graduates is selected at random from the university. Find the probability that A, exactly 6 of them have laptops. So, from the question, we know that the probability of students who having a laptop is 95%, which is 0.95. So, from the P, we can get Q equals to 0.05. And N equals to 6 because a sample of 8 undergraduates is selected. Alright. Then, exactly 6 of them have laptops, so Px equals to 6. So out of the 8, with the combination of any 6 and the probability of owning a laptop to the power of 6 times with the probability that not owning a laptop times with power 2. Then we get 0.0515. B. At most 2 or more than 7 of them own laptops. At most 2. So P x less than n equals to 2. Or, so we plus the probability that x greater than 7 because more than 7. So, in generally, we need Px equals to 0, Px equals to 1, Px equals to 2, and also Px equals to 8. More than 7, so we don't need 7. So, when Px equals to 0, it's C0, 0.95 to the power of 0, 0.05 to the power of 8. It's C1, it's C2, and it's C8. Alright, so we get 0.6634. Next, question number 4. Given a discrete random variable x, distributed binomial, okay, with n and 0.65. So please, when we see this, 0.65 here means the probability of success. So meanwhile, the probability of failure is 1 minus 0.65, which is 0.35. A. Find the value of n if Px equals to n is 0.0319. So we expand with the binomial formula, NCn times 0.65 to the power of n times 0.35 to the power of n minus n. Okay, the n minus n here. Oops. So we get 0. And then equals to 0.0319. Then from here, okay, what is NCn? Out of n objects, we choose n. We choose all the n objects. So NCn is like out of 5 objects, I choose 5 objects. How many ways are there? Only one way. So same thing, if n objects, you are choosing all the n objects, you are having one way. So NCn equals to 1. Alright. 0.65 to the power of n, we don't know, so we leave it. Okay. but 0.35 to the power of 0, something to the power of 0 is always equals to 1. So here we have 1 times 0.65 to the power of n times 1 equals to 0.0319. So simplify it, we have 0.65 to the power of n, which is 0.0319. So to get the value of n as the index, we can bring down the index by adding log for two sides. So n log 0.65 equals to log 0.0319. Then the relation from n and the log is times. So when we need n, we move the log 0.65 to the right hand side, we divide. Alright, so we divide log 0.65 on two sides, we get n equals to 8. Then B, based on the answer in A, find px greater than 2. So if we say px greater than 2, then suppose, okay, the x that we want should be 3, 4, 5, 6, 7, and 8, because our n is 8. So this is the x that we want. So 1, 2, 3, 4, 5, 6 of them. Is there any shorter way? Try to look for something that we don't want. Alright? So starting from 0, 1, and 2, we don't want. Therefore, we use the complementation method. Okay, 1 minus px equals to 0, px equals to 1, and px equals to 2. So we will get from here 1 minus 8c0, 0.65 to the power of 0, 0.35 to the power of 8, and 8c1, 8c2. So for the probability that x greater than 2, we will get 0.9747.